In a universe filled with countless stars and planets, only a few have captured our attention the way Proxima b has. Located just 4.2 light-years away from Earth, this exoplanet orbits the red dwarf star Proxima Centauri, the closest stellar neighbor to our solar system. Despite being relatively near in cosmic terms, Proxima b remained a mystery for decades. That changed recently when the James Webb Space Telescope, JWST, the most powerful observational instrument ever built, turned its attention to this intriguing world. The findings it delivered are nothing short of extraordinary and may alter our understanding of habitability, climate dynamics, and the potential for alien life. Proxima b is roughly 1.27 times the mass of Earth and lies within the so-called habitable zone of its star, where temperatures could allow for liquid water to exist. However, its proximity to Proxima Centauri, a flare-active M dwarf star, raised significant doubts about the planet's ability to support life. Scientists speculated that intense stellar radiation might have stripped away any atmosphere it once had. But JWST's observations have turned that assumption on its head. The telescope revealed spectral data that suggest Proxima b has retained a thin but persistent atmosphere, a factor that dramatically increases its potential to support life as we know it. What makes this even more fascinating is the nature of the planet's rotation. Proxima b is tidally locked, meaning one side of the planet permanently faces its star, basking in constant daylight, while the other side is cloaked in eternal darkness. This unique configuration might seem hostile at first glance, but it opens up an unexpected possibility. Between these extremes lies a region known as the Terminator Zone, a narrow band where the temperature could be just right for life to survive. In this twilight strip, the contrast between the searing heat of the day side and the frozen wasteland of the night side balances out, creating a potential haven of moderate climate. JUIC's thermal imaging and spectroscopy data suggest temperature gradients across the surface that are consistent with the presence of an atmosphere capable of distributing heat. Furthermore, subtle variations in reflected infrared light hint at cloud patterns or surface anomalies, which could be water bodies or geological formations. If these readings hold under further scrutiny, it would mean that the Terminator Zone may not only be habitable, it might be stable and long-lived, offering a cradle for microbial or even more complex life forms. Perhaps the most astonishing discovery was the detection of trace gases such as methane, carbon dioxide, and even chlorofluorocarbons, CFCs, in Proxima b's upper atmosphere. While some of these can be formed through geological or non-biological processes, others, especially CFCs, are typically considered industrial byproducts on Earth. This raises compelling questions. Could these gases be signs of biological processes or even technological activity? While far from definitive, such a chemical signature strongly warrants further investigation. The implications of this are vast. If life exists, or once existed, on Proxima b, it would mean we are not alone in the universe, and that habitable conditions can arise even under the harshest of circumstances. The fact that such a nearby world could maintain an atmosphere despite its turbulent host star suggests that life may be more resilient and more widespread than we previously believed. This could lead to a profound rethinking of how we search for life elsewhere in the cosmos. Even beyond biological considerations, the geological possibilities of Proxima b are intriguing. Variations in mineral reflectance detected by JWST suggest a surface composed of silicates and possibly liquid water reservoirs. These findings align with the idea of tectonic activity, which could help sustain a stable climate by recycling carbon and other critical elements. Tectonics also play a vital role in habitability, influencing magnetic fields and atmospheric retention. If Proxima b has even a modest magnetic field, it might shield its surface from stellar radiation and preserve its atmospheric integrity, just as Earth's magnetic field does. Another dimension to consider is the age of Proxima b. JUIC's data on the star system's activity and chemical composition suggests a mature planetary system, perhaps even older than our own. If life began there, it could have had billions of years to evolve. This presents a possibility not just for simple organisms, but potentially complex biospheres or even civilizations that have risen and fallen over immense stretches of time. Yet, not all is certain. The very flares that make Proxima Centauri such a threat could also sterilize surface life or prevent complex chemistry from taking hold. But there's a counter-argument. Perhaps life there adapted, developing subterranean habitats or protective biofilms. Some organisms on Earth already show this resilience. From bacteria living in nuclear reactors to extremophiles thriving in deep-sea vents, life finds a way. If Earth's microbial life is any indication, then Proxima b may be a reservoir of biological surprises waiting to be uncovered. The James Webb Space Telescope is equipped with instruments that allow it to peer into wavelengths of light that other telescopes can't. This gives it an unparalleled ability to detect the molecular fingerprints of gases and surface materials. Through detailed spectroscopy, scientists can reconstruct a profile of a distant planet's atmospheric composition, temperature, and even potential surface features, all from light years away. In the case of Proxima b, the telescope's near-infrared spectrograph, NIR-SPEC, and mid-infrared instrument, MIRI, played critical roles in capturing these groundbreaking signals. While direct imaging of Proxima b remains a challenge, upcoming advancements in telescope technology may change that. Future missions such as the Habitable Worlds Observatory and Earth-based telescopes like the Extremely Large Telescope, ELT, will complement JWST's findings with more precise data and higher resolution images. These efforts will refine our understanding of Proxima b's atmospheric chemistry, surface conditions, and potential biosignatures. With time, we may even develop the capability to detect artificial structures or unnatural light patterns, signs that intelligent life may have left its mark. If confirmed, the evidence gathered by JWST could mark the beginning of a new era in exoplanetary science. Proxima b would not just be another rocky world. It would become a case study in planetary survival, climate equilibrium, and possibly even evolution under extreme conditions. The idea that a habitable world could exist so close to us ignites the imagination and redefines what we consider possible in the search for extraterrestrial life. In practical terms, this discovery fuels renewed interest in interstellar exploration. Projects like Breakthrough Starshot, which aims to send small, light-powered probes to nearby star systems, gain urgency and feasibility when a compelling target like Proxima b is on the horizon. Even if human missions are still a distant dream, robotic emissaries could begin the journey within our lifetimes, collecting high-resolution images and data to confirm what JWST has suggested. There's also a philosophical shift happening. For centuries, humans have wondered if we're alone in the universe. The answer always seemed out of reach, hidden behind cosmic distances and technological barriers. Now, for the first time, we may be catching a glimpse of something extraordinary just beyond the edge of our solar system. The terminator zone of Proxima b, a narrow ribbon of balance between day and night, might represent a threshold not just for life, but for understanding our place in the cosmos. The journey is far from over. This is just the beginning of what may be the most significant chapter in humanity's quest to discover life beyond Earth. As the James Webb Space Telescope continues to unlock the secrets of distant worlds, Proxima b stands as a beacon of hope, a nearby world that might one day go from a mysterious dot in the sky to a confirmed second cradle of life.